Hello everyone, slide is visible. Please just confirm. You can write in the chat box also. Please confirm. You can write in the chat box also. So I'll wait few minutes for maybe another participants will join. Then we'll discuss about the first week hydraulic engineering. So briefly I will discuss some topics related to your first week, and then after I'll solve some problems. So let us wait 5 minutes. Hello, I'm audible. Please just confirm.
Yes, sir.
Okay, okay, fine. So now let us start. First, I'm thinking we'll solve the problem. Then after I'll discuss some basic concept because you have already learned in the first week about the introduction of the fluid mechanics. So we'll solve some problems which is the previous year your NPTEL hydraulic engineering questions. So now we'll start. So you will write your answer in the chat box. So first question is a fluid occupied 24 meter cube. Calculate the specific volume in kg meter cube per kg if the fluid mass is 16 kg. So please you just try to solve your answer question. Then after you will reply whether option A, B, C, D which one is correct. Option A is 0.667, option B 1, option C 1.334 and option D 1.5. So please everyone try to solve using your pen and copy, and then you just try to write your answer in the chat box or you can reply. So please you have 2-3 minutes. So please try to solve the first question. So basically I am Om Prakash Maurya from IIT Guwahati. So I'm a PMRF research scholar. That's why I'm taking this PMRF NPTEL of hydraulic engineering. So please try to solve first your question number 1, and you can write your answer in the chat box. So just I have written some message in the chat box. So if you will feel you can write your answer in the chat box. Okay, you are telling the option number D. Okay, another participant also you try to write your answer. The Manikumar is telling the option number D is correct. Okay, we'll see. Just I'm waiting for few answer. Okay, okay. Okay, now I want to solve. So here in the question, volume is given already. Volume is your 24 meter cube, and you need to calculate your specific volume. If you not know the formula, here is unit is given, you can very easily identify. That is your volume means meter cube and kg means mass. That is kg. So here your specific volume is nothing but volume, that is 24 divided by 16. So how much? Just try to calculate please. So D option will be correct or not? 1.5. So option D will be correct for this question. So now we'll moving on the next question. Next question is your question number 2. The cavitation is caused by, so please everyone try to give your answer. The cavitation is caused by your high velocity, low pressure or high temperature. So I have the picture of cavitation also, so I will show you. Please just to try to give your answer in the chat box, then after we'll discuss about the cavitation. Okay, B option, low pressure. Okay, I'm waiting for another response also. So please everyone try to participate, because you have joined here, then it means you need to participate in the this discussion about the fluid mechanics. So please another participants, you write your answer in the chat box. Okay, Abdul is telling option A. Another participant want to give your answer? Okay, option B. Okay, the cavitation is due to the low pressure. And how look like the cavitation? Just please wait few minutes. I want to show you. Just I want to share the PPT, another document. So I'll just show you how it look like. Yes, this one. So you can see here. This is the picture of cavitation. This is a picture of cavitation. Very easily you can see here. This is the cavitation. So it is due to the low pressure. Due to the low pressure, bubble form, and then high pressure, the bubble burst. Due to the burst action, your the surface of your, if the fluid is flowing in the pipe, the surface of the pipe will damage like that. Remember please. So now we'll continue with the questions. Okay, so your next question is the low pressure, and here the some explanation is given. The cavitation is defined as the process of formation of vapor phase of liquid when it's subjected to reduced pressure at constant ambient temperature. So this is a little bit uh, definition. Now we'll move with the question number 3. Very important. Your analysis part of the fluid mechanics start with this concept only. So just please try to focus on this question number 3. The shear stress in Newtonian fluid is proportional to pressure, strain rate, or option D is the inverse of the viscosity. The shear stress in the Newtonian fluid is proportional to. So everyone please try to give your answer in the chat box for question number 3. You have 2-3 minutes, just think about that and try to give your answer. Okay, strain rate option C. Okay, Abdul is telling option C. Tabis is telling also option C. And the sun. Okay, everyone telling is option C. Definitely, this is your Newton's law of viscosity. Little bit I'll discuss here. What is the Newton's law of viscosity for another participants? So basically, the Newton's law of viscosity for Newtonian fluid, your shear stress is proportional to your uh, strain rate du by dy, or you can say d phi by dy. That is the your angle. So why dy I am writing here? Just your velocity distribution like that. So if this velocity is your u, this is your u plus du, and this, if in this direction your y and in this direction if x, so this is your du and this is your dy, and how your velocity changes from as you go from here to here, that is the as you move dy distance, your velocity changes only du. So that's why, so this is the logic behind how it is related to your shear stress with shear strain. And when you will remove this proportionality constant, one constant will come, or one dynamic viscosity term will come, du by dy. So based on that, I will solve some problems. So now we'll move on the next question, question number your 4. So here please try to give your answer. Which of the following is an example of phenomena of surface tension? Raindrop, rise of sap in tree, break up the liquid jets, all of the above. So which option is correct? Just please try to give your answer. Okay, option D. Yes, good. Yes, option D. Another participants also please try to give your answer, because this is a very basic question. So it will be very uh, okay, good. Okay, everyone telling is option D. Good. So definitely option D will be correct. Now we'll move on the next question. So the next question is question number 5, a very small numerical. The equivalent head of mercury corresponding to 8 kg, 8 kilopascal is, and you can take the specific gravity of mercury is 13.6. So which option is correct? Whether A, B, C, D. The option A is 6 centimeter, B option 3 centimeter, C option is 3.5 centimeter, and D option is 2 centimeter. So here you need to give the answer, the equivalent head corresponding to 8 kilopascal of mercury. So now please. Okay. Option A. Okay, I am waiting for another participant. Give the answer. Please everyone try to solve, because this is a discussion kind of thing. So if you will try to solve, then it will be good for you for your final exam, as well as if you are preparing for the gate exam also, it will be benefit. Now I want to solve this question, so please everyone focus. So we are talking about here the equivalent head of mercury corresponding to 8 kilopascal. Your pressure is 8 kilopascal, you can say 8,000 pascal. Okay, so your pressure rho gh. So we are talking about here the h height. So the rho of mercury is specific gravity into the density of water. So 13600, 13600 into 9.81 into your height. How much? H. Here is 8,000 is given already. So if I write this 9.81 is 10, so your h is equal to 8 by 136. If I write in centimeter, 100. So 800. Why I am writing centimeter? Because your answer is given centimeter. 136. So please try to calculate how much is coming. Please write your answer in the chat box. When you will divide 800 by 136, how much? Please at least everyone just divide the 800 by 136. How much is? Let me just divide. It is 5.88. So definitely your 6, yes, everyone, your 6 will be correct answer. Because we need to select the most appropriate. So definitely your option A will be correct for this question. Now we'll move on the next question. Next question is, okay, question number 6. What is the phenomena, which phenomena by which a liquid rise into a thin glass tube above or below its general value, which whether it will be surface tension, capillarity, cohesion, and adhesion. This phenomena, your surface of water will rise and fall in the glass, thin glass. So this phenomena is known as by a particular term. So please everyone try to give your answer. Okay, so Manikumari is telling option B, capillarity. Okay, another participant also try to give your answer, please. If you are joined here, then it will be uh, okay, good. Tavis is telling B. Okay, everyone telling is B. Definitely, the B option will be correct. Yes, B option will be correct for this question. So now we'll move on the next question. Ranjit Kumar, you want to tell something? Because you have raised the hand. So if you not have any questions, so you can put it down. Okay, I have put it down. Okay, now we'll move on the next question. Question number 7. So, which of the following is the dimension of a specific gravity? You can see here the specific gravity dimension. So please everyone try to give the answer of this question. So the answer of this question I'm expecting from all. So please try to give your answer. For question number 7. Everyone please try to. Okay, 2 student already given the answer. So another participant also please. Okay, someone telling option B, someone telling option A. Okay, so let me discuss. So your specific gravity is nothing but you know from your very fundamental. Specific gravity is the ratio of your density of something and density of something. So I'll not discuss about here anything. So A, B, I want to write here. The specific gravity. So the unit will be the same. Kg per meter cube. Here also kg per meter cube. So unit will be same. Unit will be cancelled out. So definitely your option A will be correct. Remember please always. Now the next question is surface tension is due to option A cohesion and adhesion, option B cohesion only, option C adhesion only, and option D none of the above. So please everyone try to give your answer. Surface tension is due to. Okay. Okay, two student is telling option A. Okay. Amit is telling option A. Okay, most of the student telling option A. Okay, let me just show you the answer. Which option will be correct? Option B will be correct. And how option B will be correct? Just I want to show you some example. So please wait few minutes. Let me share the PPT. So your surface tension part is here. So here you can focus. Here is the two actually the molecules of the liquid. So let me just draw again here. So if this is free surface and this is your inside, so everywhere the cohesion of the particle, because around this particle lots of particle is present, lots of particle, every particle attract each other. So what will happen? So only the cohesion, not due to the adhesion, because of here the surface tension will be act on the surface of the your liquid. So here if this is surface, so this particle is attracting the surface particle, this particle is attracting surface particle, this particle is attracting surface particle, this particle also attracting this particle also attracting this particle. What will happen? One tension will form at the, because here if you will see, if you are something stretching in this direction, definitely tension will be formed on the surface. So that's why you can see here, now insects, you can see the figure number B, a water stride sitting on the top. Here you can see insects, you can say here insect is sitting on the top of the water. So because of this surface tension, so remember always please, the surface tension is due to the cohesion. So now we'll move on the next, your next question. Okay, question is not visible. Why it is not visible? So now we'll move on the next question. Question number 7 we have done already, and question number 8 we have already completed. Now question number 9. So question number 9 is, for an incompressible fluid, does density vary with temperature and pressure? For incompressible, we are talking about here the incompressible fluid, does density vary with temperature and pressure? Option A, it varies for all temperature and pressure range. It remain constant. Option C, it varies only for lower value of temperature and pressure. It varies only for higher value of temperature and pressure. So please everyone try to give your answer for question number 9. Okay. Okay, option B is telling most of the student. Option D is telling someone, Amit Kumar is telling option D, it varies only for higher value of temperature and pressure. Another student also want to give the answer. I'm waiting few minutes. So please, another student, if you want to. Okay. Let me solve. Let me just discuss, because you are not a numerical value. So for an incompressible fluid, remember please always, the compressible fluid means what? The compressible fluid means you can compress the fluid. Just remember with the terminology. Compress means when you will compress, definitely your pressure will vary. With pressure it will be vary. That is, the density will be vary. Just for your understanding of few student, and I have drawn here the two box or two container, you can say. The liquid at that level initially, and your plunger at that level. Now if you just press the plunger, let us suppose your number of molecule n. Here definitely number of molecule will be the same, n, but the volume of, here volume is V1, or you can say V. Here definitely your volume will be V minus. Some volume will be reduces. You can think. So definitely your density is what? Mass by volume. Mass definitely depend on the number of molecules. So just you think, if the volume it reduce, that is for a compressible fluid, definitely your density will vary with the pressure. But in this case, for incompressible fluids, always remember please, it remain constant. Now we'll move on the next question. I was talking about the compressible fluid here. But if the fluid is incompressible, you cannot compress, then definitely your density will be changed very negligible. That is the, uh, for engineering purpose will not consider. Actually, we define the compressible fluid like that. The density will not vary. Okay, here you just see the answer. But always please think, which one of the following pressure unit represent the least pressure? So least pressure, that is the millibar mm of Hg, and your Newton per mm square, and the kg of centimeter. Definitely your the least pressure will be millibar. Now we'll move on the next question. Next question will be, here you can see the answer. 1 atmosphere is equal to 10.1 meter of water, 760 mm of Hg, 1013 millibar, and 101.3 kilopascal, 1.013 your kgf centimeter square. So just you can think here. Now we'll move on the question number 11. Your A hydrometer is used to determine zero relative humidity, surface tension of liquid, specific gravity of liquid, and the viscosity of liquid. So please try to give the answer of this question. So this question from the application of fluid, the instrument application in fluid mechanics. So please try to give the answer. The hydrometer is used to determine. Okay, I'm waiting. One student is telling option C. Okay. Okay, C. Many students telling the option C. Specific gravity of the liquid. Okay, good. Now we'll move on the next question. Oh, question number 12. So the unit of dynamic viscosity of liquid, of the fluid. So please everyone try to give the answer. So question number 12, the unit of dynamic viscosity of fluid is meter square per second, Newton second per meter square. Option C, Pascal second meter per meter square. Option D, kg second square per meter square. Okay, most of the student is telling option. Okay, student is asking the PDF about the PDF of this question. So no, NPTEL will share with you. The NPTEL team will share with you. Okay, Ujjwal, NPTEL team will share everything. NPTEL team will share one link, that is the Google Drive link, and I'll upload everything in the Google Drive link. NPTEL also share the YouTube link of this, whatever I'm today is discussing about the fluid mechanics, about this topic and week 1. So the video, I'll upload this video on YouTube and I'll submit the link of NPTEL team, and NPTEL team will share with you uh, all the video link as well as the PDF of this question. So don't worry. Okay, most of the student telling B. For few student, I want to discuss about this question, how you will calculate the unit of dynamic viscosity. Okay, thank you. So how you will calculate? So everyone know about the your dynamic viscosity is related like that, du by dy. So this is the pressure by stress, so force by area, and you want to calculate the unit of your dynamic viscosity, and this is your velocity and this is your depth. So force, what is force? Mass into acceleration divided by A. Now dynamic viscosity meter, that is your definitely Y. So here your mass, M for mass, so it is kg, A meter square per second, meter per second square. So meter per second square, oh sorry, for few students just I want to discuss, and area is meter square, and again meter per second, here is mu and here meter. So just think, the this meter and this meter will be cancel out, 1 second and second will be cancel out, and this meter and meter will be cancel out, only 1 meter will be remain here. Okay, so what is remaining? So kg by second, kg by second, here meter. So this is the your dimension of the unit of your dynamic viscosity in terms of kg. But here you can also check, but in terms of kg your answer is not matching with this, so it is not correct for kg. Now in terms of Newton, how we will write? Force unit is Newton divided by meter square. Now equal to your dynamic viscosity and meter square now meter per second divided by meter. Okay, so 1 meter will be cancel out, and your second, so Newton at this second will be come here, Newton second, and meter will be. So in form of Newton, your unit is Newton second per meter square. Definitely your option B is matching with this. So option B will be correct. So this is all about for your hydraulic engineering, the previous year hydraulic engineering. Now I want to show some another questions also, which is in my PPT. So it is not allowing. Wait few minutes. So it may be allow. Yes. So actually for theory, I'll just show you the very conceptual theory. Not I'll teach from your beginning to last for first week. Just I'll show the important points. So just I'll follow for this the Single Symbala book, your Single Symbala book of the fluid mechanics. So here just you can see the your surface area, how your shear stress actually the tangential force, and your normal stress is the normal of the your surface. Here you can see just the shear stress is the stress parallel to the rubber. So like that, actually just I want to show you questions because you have already done, you already know about this such simple concepts. So just I want to go with the questions. So this is very important question. So if, okay, this is about the capillary rise. So just I want to show you the derivation of the capillary rise. If you want to see here, this is the capillary. So here if I write the for balance the summation of y is equal to 0. If I balance these things, so what will be in vertical direction, your vertical direction 2 pi r 2 pi r sigma s cos phi, and in downward direction w. So 2 pi r sigma s cos phi is equal to your weight. So your weight, how you will calculate the weight? The unit weight of water, if it is water, unit weight of a liquid, actually I want to write here, unit weight of liquid into, this is L, unit weight of liquid into your volume, because your unit weight formula is what? Weight by volume. So weight is equal to unit weight into volume, and volume is nothing but volume is pi by 4 into d square, the diameter of this tube, into height, so h, and here 2 pi r sigma s. R is the radius of your, just you can see here, the that is the 2r is the diameter of cos phi, diameter of the tube. So your pi and pi will be cancel out. Your 2r means what? 2r means d, so this 2r and 1 d will be cancel out, so only d will be remain here. So your sigma s cos phi divided by gamma liquid, and 4 will be go this side, and only t will be remaining. So this is the formula of your capillary rise in the tube. So based on that, we have one question of capillary rise. So you can see here, and you can just take the screenshot of your if you are using mobile or computer or laptop. We just take the screenshot for this question. Now we'll move on the next question. So okay, so now I want to move on the next question, which is already solved here. So the next question is very important. So here you can see a 50 centimeter, 30 centimeter and 20 centimeter block weight 150 Newton is to be moved at a constant velocity 0.8 meter per second on an inclined surface with a friction coefficient is given already, you 0.27. Option A, determine the force F that need to be applied in the horizontal direction. Okay, you have to calculate this value F. You need to calculate the F value. And question B, if a 0.4 mm thick oil film with a dynamic viscosity of 0.012 Pascal is applied between the block and inclined surface, determine the percentage reduction in the required force. So I'll not take much time here. So just you can take the screenshot of this question and try to solve at your home, and we'll discuss on the next class. But just for just I want to give you idea how you will calculate. So first option you need to calculate simply just what you have learned in the your mechanics, engineering mechanics. With this concept you will try to find out this F value. Then after, if someone put the liquid between this block and the inclined plane, then definitely your friction value will become, your the coefficient of friction definitely will be reduced. And if it is not given, definitely in the liquid case your formula will be different. So just try to think on that, and how much percentage will be reduced. So this question I'll discuss in the next class. So please everyone take the screenshot of this question. So we'll move on the next question. The next question is from the previous year, your fluid mechanics. So similar type of questions also I have put it here from the Sinjal Simbala book. So you please everyone try to think and try to, you can also take a screenshot of this question, question number 2110 and question number 2115. So now I want to move on the your previous year fluid mechanics NPTEL. So in Newtonian fluid for a given shear stress, the rate at which fluid is deformed. Option A, independent of kinematic viscosity, directly proportional to the dynamic viscosity, inversely proportional to the dynamic viscosity. Option D, none of the above. So please everyone try to solve this question. So first question actually. So which option is correct for the question number first? Okay, option B, everyone telling. Okay, option B, directly proportional to the dynamic viscosity. Your shear stress for a given shear stress value is given to you already. The rate at which fluid deform, it will be directly or inversely. Just try to think. Shear stress is given means shear stress is constant already. In question is already telling. So now you can think. Please everyone try to participate in the discussion part, so it will be benefit for you. Whatever you know about the questions, the answer, you just try to write in the chat box. Now the next question is control volume. First, okay, I want to discuss the first question. The second question is control volume. I'll discuss what is control volume and system. But first we need to concentrate on the first question. Oh, sorry. The first question is your from the Newton's law of viscosity. You can say that. So in the question is given in Newtonian fluid for a given shear stress. For a given shear stress means let's suppose the shear stress value is given 10 mu du by dy. Okay. So here the rate at which fluid deform. So definitely mu du by dy. So this is rate of fluid. Just I'll write here the rate, and here is your 10 by mu. So rate is inversely proportional to, not directly proportional to, rate is inversely proportional to your dynamic viscosity. Remember please, as your fluid properties, the dynamic viscosity is the fluid properties, because of the for your honey the dynamic viscosity is different than when we will compare with the water. So as definitely if a constant shear stress, you have the constant shear stress, so your rate of deformation will depend on whether it is you are deforming with 10 shear stress water, whether you are deforming honey and another fluids. So remember please, it is inversely proportional to, means more, means here more mu less deformation, means honey will less deform than water H2O. So remember please. The next question is a control volume implies. So control volume, first you all try to give your answer, then I'll discuss. A control volume, first option, an isolated system, a fixed region in a space, option C a closed system, option D a specified mass in fluid flow. So everyone please try to participate. So for question number 2, after this question I'll take 5-minute break, and you can also take or you may join here. Okay, option D, you are telling option D. So everyone try to give the answer of this question please. A fixed region in a space, okay, good. Option B, a specified mass in fluid, okay. Okay, your control volume and system, we have two things for analysis of fluid, two approaches. One is the control volume approach, another is the system approach. So system is nothing but, the system definition is this: a specified mass in fluid, and your control volume is definition is a fixed region in space. So remember please always, a control volume and your system approach. We have to generally we follow in the fluid mechanics the fixed region in a space, that is the control volume approach. So the next question is here is given. So now I want to take 5 minute break. If anyone want to take, you can take. Otherwise, you try to give the answer of this question. Question 1, 2, 3. I think two question is from previous, but 1 and 2 in another question. So please try to give your answer, or you can take the 5 minute break also. Okay, so kinematic viscosity and 3a, the condition of no slip at rigid boundary is applicable to. Okay, okay, let me discuss. So the condition of no slip, everyone know what is no slip. So not know, just you just focus on the on this slide. The no slip is look like that. If you will see here, that is on the surface of your, on the surface of body. This is the surface of the body. If you will see here, your fluid velocity is almost zero here, and it is increasing very slowly near the surface, then after it attain the constant velocity after a few. So here you can see in the simplified way the representation of your velocity distribution in 2D. As the conclusion here, as your fluid interact with the surface or solid surface, let us say the plate, at the surface your velocity will be zero, and this condition is known as no slip condition. And the question is here, it is applicable for all fluid or Newtonian fluid or real fluid or ideal fluid? Definitely it will be for all real fluid. Remember always. The control volume, definitely it is a fixed space, and the poise is the unit of dynamic viscosity, kinematic viscosity, and the vapor pressure or the surface tension. So some student is telling the option number kinematic viscosity is not like that. I think for kinematic viscosity, your stock is the unit of kinematic viscosity. For dynamic viscosity, your unit will be poise. Always remember, please. Yes. Okay, now we'll move on the next question. Next question is this. Match the list 1 and list 2, and select the correct answer using the code given below. The code is PQRS, and here the 1, 2, 3, 4. So please everyone participate. And question 4 we have already solved. So question 3, the property which explain the spherical nature of a drop of fluid. So which, whether you will match with 1, 2, 3, 4, 5. Q list, that is the your code key is the Q is the property which explain cavitation in the fluid. Next, the property which explain rise of water in tree, and next the property which explain flow of oil jet. And the list to viscosity, surface tension, compressibility, vapor pressure, and capillarity. So please just think on that and try to give your answer. You can expect such type of questions in your competitive exam also, and you can think about the first question whatever I have shown you on inclined plane on the gate exam also. So these are the very basic and fundamental, because these question is linked from your previous knowledge also, that is your engineering mechanics. So that's such type of question you can expect in your competitive exam, as well as definitely your this final exam of the hydraulic engineering NPTEL. So please try to give your answer of question number 3 here. Okay, you are telling the option C, or Abdul is telling option C. So another student, please try to give your answer. Okay. What is your last date of submission of the first NPTEL assignment? First week of the NPTEL assignment. So anyone can confirm? Anyone can write, please. What is your first last date of the first week assignment submission? Whether we are delay or I am ahead. Okay, 5th Feb. Okay. Okay, good. So definitely these questions will help you for solving your assignment. That's why I was asking, because whether the last date is coming or gone. Okay, good. So please try to give your answer. Okay, A, someone telling A. Okay, I am waiting for another student response. 3C and 4A. How you are telling the 4A? Because we have already solved here. The question is asking the unit of dynamic viscosity. Abdul, please think about that. Or whether it will be meter square per second or okay. We are not talking about here the kinematic viscosity. So for kinematic viscosity, answer will be meter square per second, but for your dynamic viscosity, definitely. Okay, so let us discuss about the question number 3. Your question number 3 is talking about the match the list. The first is the property which explain the spherical nature of drop. We are already discussed about here. If you will see the pictorial representation what I was showing during your surface tension. So just I want to show you in the pictorial representation of surface tension, where it is. Okay, here you can see this, the first that is the first is talking about the spherical nature of your drop, which is due to your surface tension. So you can match very easily your P, you can match with the 2. Now for such type of objective type questions, after matching 1, you just go on your that is your option part. So just see, P is matching with 3, not this is wrong, this is correct, this is okay. Only one option having the P is matching with 2, so definitely your C option will be correct. We will not check the another. This is the way of solving the such type of question, that is the objective type of question. But here just we are discussing, so we'll see one by one. The property which explain cavitation in the fluid, definitely your the vapor pressure related to. And the property which explain the rise of water in the tree, definitely will be capillarity. And your viscosity, that is the property which explain the oil jet, that is the S is related to 1. So now we'll move on the next question. With increase in temperature, with increase of temperature, the viscosity of fluid, we are talking about here the fluid, so does not change, always increase, always decrease. Increase if it is fluid, if the fluid is gas, and decrease if it is liquid. So please read carefully all options and try to give your answer for question number 5. Everyone, please. Everyone try to participate. It's the very basic and fundamental questions. Option D. Okay, Abdul is telling option D. Okay. Bhavesh is telling C. Okay. Always decrease. Tavis is telling option D. Okay. Okay. Most of the student telling D. Okay. Good. Okay. Murmu is also telling D option. Yes, D will be correct because let me just discuss. Before going on answer of the question number 5, I want to show you some pictorial representation of your liquid as well as gas. So you can focus here on the three arrangement of atom of different phase. First phase is your solid, second is liquid, and third phase is gas. You can see here the molecules, the distance between the molecules here is more in case of gas compared to your liquid followed by solid. So in case of gas, the random motion, always remember please here then see if you will read the the individual molecules move about at random in the gas phase, move randomly. In case of liquid, the group of molecules move about each other. Here you can see the direction in the liquid phase, and in the solid phase the molecules are at relatively fixed position in the solid. Relatively fixed position, you can think about it, the molecules in the solid is fixed position. Relatively means very minimum. When we will compare relatively means the relative means when you will compare with two molecules, the distance you will see in case of the solid it will be fixed, but in case of liquid little bit your molecules will be moved, and in case of gas random motion will happen in case of the gas phase. So what about if you will think about the first question? This is the question number 5. The question 5 is, where is this one? So question 5, in one, here I have two container and I am increasing the temperature in here also and here also, increasing the temperature. The random motion will increase here. The random motion will increase here and here also. But in this case, what will happen? Your that is the in case of gas, it will increase due to the random motion increase. Your the viscosity of the gas will increase, always remember, due to the random motion. But here in case of liquid the viscosity will be decrease. Viscosity will be decrease in the your liquid phase, always remember. Now question number 6. The continuum approach in fluid mechanics is valid when? Continuum approach, this is the first and the basic fundamental. This is the fundamental assumption or the first assumption in the fluid mechanics. That is the continuum fluid mechanics. Actually, when you will analyze your physical thinking about the fluid mechanics, or if you want to write the mathematical equation of the fluid mechanics or physics, so what you need to first you need to consider that is the fundamental assumption, which is the continuum approach. So continuum approach in the fluid mechanics is valid when option A, the compressibility is very high, option B, the viscosity is low, option C, the mean free path of molecule is much smaller compared to the characteristics dimension, and option D, your Mach number is greater than 1, where m is the Mach number. So please, for question number 6, try to give your answer in the chat box. Question number 6. And okay, first you try to give the answer, then I'll explain a little bit about the question number 6. So everyone, please try to give your answer. Okay. uh, Murmu is telling option A, compressibility is very high. Okay. Another student, please also. Okay. Ranjit is also telling A. Ujjwal also telling A. Another student, please also try to give your answer. Okay, now I want to discuss. So actually the continuum approach, what is continuum approach? For this I want to show you some basic concepts. So here this slide is visible, hope, to all of you. So just here we have assumed molecule 1 and molecule 2, and this is your diameter of the molecule, and this is L. L is what? The distance between center to center distance between the molecules, which is more greater than your D. Okay. So here your L is what? L is nothing but your what we are discussing about in this question. Let me just go here. Yes. Your mean free path is nothing but L. Mean free path is L. So the mean free path of molecule is much smaller compared to the your characteristics dimension. Then you can assume the continuum approach. Mean free path means what was the L, and your characteristics dimension was nothing but was D. When it is small, remember please, the mean free path of the molecule is much smaller compared to the characteristics dimension, then you can utilize your continuum approach. We have seen in case of fluid, so this is valid. So that's why we are assuming the continuum approach. We can assume continuum approach means nothing but, for just for simple definition, the all fluid connect with each other, all particle connect with each other, there is no gap between the fluid, there is no gap, there is no gap between the your fluid. This is the assumption of. If you will think, in case of gas it might be this assumption will fail somewhere, but at the at basic level you can think about that continuum approach, but in case of liquid definitely it will be valid. So now we'll move on the next question. Next question, shear stress in Newtonian fluid is proportional to, this question we have already solved. The surface tension has a unit of, this question, the question number 8, please try to give the answer for question number 8. The surface tension has a unit of force per unit length, force per unit area, force per unit volume, and cannot say. Cannot say means there is no dimension of surface tension, the option D. So which option is correct, whether A, B, C, D? Okay. Okay, another student please also try to participate. Okay. Okay, definitely option A will be correct, force per unit length. So we'll move on the next question. The path traced by a single fluid particle, we are talking about here the single fluid particle. So is streamline, straight line, path line, or none of the above? Which one is correct? Just please try to think about that. Okay, path line, someone telling, A telling someone, Tabis is telling C. Another student please also try to give your answer. Maybe this question is not need to ask here because this is related to your fluid kinematic, but okay, I'll discuss about streamline, straight line, and the path line. So definitely it will be the path line, but for few student now I want to discuss what is your path line. First I want to discuss the path line. Path line is nothing but, if it is, let us suppose a fluid, this is the fluid domain, here fluid is moving, so the path line is the trajectory of one fluid particle, how one, this let us suppose the numbering 1, this how your one, that is the one number fluid particle moving in the fluid domain. So this path is known as path line. What is straight line? Straight line is nothing but from a particular location, let us suppose from this location, whatever the fluid particle is passing, 1 passing, 2 passing, let us suppose number 3 particle is passing, and how it moving. Here let's suppose 3, here let's suppose 2, here let's suppose 1. So whatever the particle is passing from here, the trajectory or the locus of this particle is known as your strike line. And what is a streamline? Streamline is nothing but is a curve in a fluid domain which gives the tangent along that curve, gives the direction of velocity, gives the velocity, you can say. So the basic difference between your streamline, straight line, and the path line. Now we'll move on the next question. The flow in which viscosity of fluid at a particular fixed point does not change with time. Unsteady flow, oscillatory flow, steady flow, and the periodic flow. Which option is correct for question number 10? Please try to give your answer for question number 10. Okay, many students telling option C. Okay, that is the steady flow. The flow in which velocity of fluid at a particular fixed point does not change with time. Definitely it will be a steady flow. Meaning, let us suppose a fluid, let us suppose pipe flow, water is flowing. You want to measure velocity in this at that particular location using some device. So at t is equal to, let us suppose, 10 a.m., your t1, so your v1 is 2 meter per second, and t2, that is the 12, or you can say the 11 a.m., your v2 is 2 meter per second. Now t3, let us suppose we have measured in evening also, 4 p.m., your v3 is 2 meter per second. That means, and here also, here you have measured at t1 is equal to 10 a.m., t2 is equal to 11 a.m., and t3 is equal to your 4 p.m. Here v1 is equal to 3 meter per second, v2 is equal to 3 meter per second, and v3 is equal to 3 meter per second. So at a particular point with respect to time, when we will measure velocity, it is constant. You can see here at 10 a.m., 11 a.m., 4 p.m., your velocity is 3 meter per second at this particular point. When we will move another point at same time, when we will measure, your velocity is at a particular point always. Let us suppose if you will measure here, maybe your velocity will be different. Let us suppose if here 3, here 2, maybe here is 4 meter per second, all three times. So but at a particular point is fixed, so such type of flow is known as your steady flow, but it is non-uniform, because uniform means at particular time everywhere. If here is 3 meter per second, here also should be 3 meter per second, here also should be 3 meter per second. Maybe another time here is 4 meter per second, here 4 meter per second. Let us suppose as t1 is equal to 3 and t2 is equal to your 4 meter per second, 4 meter per second. As you changing the time, your velocity changing, but at a particular time along the your pipe, the velocity is same. Such type of flow is known as uniform flow. But here we are talking about at a particular point. So at a particular point, if velocity is not changing with respect to time, definitely it will be a steady flow. Now we'll move on the next question. Question 11. A fluid is one which can be defined as a substance, has same shear stress at all points, can deform indefinitely under the action of a smallest shear force. And option C has a small shear stress in all direction. Option D is particularly incompressible. So please, this is the very fundamental and the first This is the first line of the fluid mechanics, you can say. No, this is the first class. This is the first class of NPTEL, the first week. So, Ujjwal, I'm talking about your question. And the meeting, the link of this video, whatever we are discussing, the link of this video you will get maybe after 2 hours. NPTEL give you later. Okay, I'll share here my YouTube. Actually, this is the uh, YouTube channel uh, which is dedicated to only for NPTEL course, which is the NPTEL. Actually, I'll share you the YouTube channel. Just wait few minutes, please. Okay, so here is the this is the channel ID for which is for NPTEL courses. So please you can go through this. Not NPTEL courses. This is the for a YouTube channel for actually whatever I have teased already. I have teased 3 times the fluid mechanics. Uh, that is the 1 times of hydraulic engineering and 2 times of the fluid mechanics, which is run by IIT Guwahati. So all video are available at that channel, and the same channel link will provided by the NPTEL also maybe after 1 days or 2 days, but after 2 hours you can access this video. So okay, we are discussing about the question number 11. Option D, everyone telling. Oh, why option D is telling? Oh no no, option D should not be correct. So please think about the question number 11. Just please everyone check whether it is working or not. Every video is in public mode, so might be working. Okay, let close. Okay, good. So for your future, you can just okay. Okay, option C is telling Manoj. No, option B will be correct for your this question number 11. So please keep it this channel link for your future videos, or definitely NPTEL will share with you also. So for question number 11, fluid is one which can be defined as a substance can deform uh, indefinitely under action of a smallest shear stress, because your fluid cannot resist any shear stress, any shear forces. So that's why this definition, this is the this is the basic definition of the fluid. Remember always. So fluid is a substance which deform continuously under a smallest shear force, under the action of a smallest shear force, you can say also. Question number 12. The kinematic viscosity is defined as, please everyone try to give the answer for question number 12. The kinematic viscosity is defined as what? Okay, it's okay as well. And on this channel actually I have solved the lots of fluid mechanics problems. So if anyone interested to learn the fluid mechanics problems, so please go one by one. Okay, your kinematic viscosity is the ratio of dynamic viscosity and density. Yes, it is correct. Option B, everyone telling. Okay, sometimes people forget, sometimes some student forget about the whether it is the ratio of density or dynamic viscosity. Remember please, here is we are talking about kinematic viscosity. Definitely your viscosity term will be in the nominator. In denominator part, another that is the density will appear. So remember always, due to this the nomenclature, remember. The poise is the unit of, you know already, viscosity. For question number 4, for a fluid, the shear stress was found to be directly proportional to the rate of angular deformation. Directly proportional to the fluid is classified as dilatant fluid, and your Newtonian, non-Newtonian, and the thixotropic. Directly proportional to the rate of angular deformation. So question number 4 in the slide. Okay. For question 13, Abdul is telling C, and for question 4, B. Okay. Another student, please also. Manoj is telling option D, thixotropy. Okay. Other student, please also. Okay, everyone telling D, definite B, or definitely your B will be correct. Manoj, remember your that is the shear stress directly proportional to we are talking about. So it is directly proportional to your angular deformation. Means why? Means what here? D phi by your dy. What is mean by angular deformation? Here in the first slide I have pictorial representation of this. Here you can say this is the alpha. Whatever the alpha is here, this is the angular deformation. Remember. So that's, you can say here phi also. So that angle I have written in terms of d phi by, that is here represented where is phi, that is you can say the alpha, d alpha by dy. Now we'll move on the question number 14 in this slide. A Newtonian fluid is defined as a fluid which is incompressible and non-viscous, obey Newton's law of viscosity, is highly viscous. Option D is compressible and non-viscous. Newtonian fluid. The definition of Newtonian fluid here, you need to think about that. Question number 14. Okay, Kumari is telling option B, obey the Newton's law of viscosity. Okay, another student, please also participate. Okay, everyone telling it needs to follow the Newton's law of viscosity or obey the Newton's law of viscosity. Yes, definitely your option uh, B will be correct for question number 14 in this slide. Question number 15, very interesting question. Two horizontal plates are placed 14 mm apart and space between them filled with an oil viscosity 1.4 Newton second per meter square. If the upper plate move with 2.5 meter per second, the shear stress in the oil is. So please first you take attempt. You have the 4-5 minutes for this question. So please try to give your answer for this question. Question number 15. Everyone please read the question very carefully and try to solve this question. Question number 15. The viscosity of the oil is given 1.4 Newton second per meter square. So you please write the numerical value in the chat box, which of whatever is coming. Okay, 250 you are telling 250 Newton second. Okay, Newton square meter you are writing. Okay. Another student please also try to give your answer. This is the very basic question. For another student you have only 1 minute. Okay, shear stress formula you know already. Everyone know the shear stress formula. Okay, Kumari is also telling 250. Okay, let me just check whether you are correct or wrong. So shear stress tau is equal to mu and du by dy you know already. But here is the distance between your plate, two plate, let us assume here the two plate, this distance is very small, that is a 14 mm. 14 mm means you know already the change in velocity is very minimum, so you can assume that is a negligible change when you will compare from here velocity and here velocity. So you can assume v by, that is your velocity change linear, like that, linear. Actual your velocity is, if the plate distance is much, your velocity change like that. But here the velocity is that is your space between the plate is very low, your velocity change linear, like that. In zoom view, if I show you, like that, linear. So linearly change means you can write u by y. If this is your upper plate is moving with velocity u and the distance is y, let us suppose y is equal to 14 mm, so you can write this formula like that. So now you need to calculate tau. Dynamic viscosity given 1.4 Newton second. Everything is SI unit. So, and now velocity is given 2.5 meter per second and 14 mm. So you need to write -3 for meter. So now you can calculate. Here you will remove 1 point, here 10 will come, and here also this is, so 14 will be cancel out. So 25 divided by 100, and this will go up, you can write here 30. So very easily you will get 250 Newton per meter square. Okay, so everyone correct. So the next question, question number 16. A liquid of density rho density and dynamic viscosity mu flow steadily down in inclined plane at a inclined plane in a thin sheet of constant thickness T. The shear stress on the bottom surface due to the liquid flow is, so think please. First you try to think within, oh, we have not time much, so I want to discuss. Or you can just think. You can just think. Let me first draw the inclined plane, which is theta. So please everyone first try to give the answer in 2 minutes. You have 2 minutes. We are talking about here the shear stress. So please everyone write, try to write. So here velocity is not given, remember please. So you cannot use the above concept what we have discussed in the question number 15. You cannot apply here. Okay, let me discuss. So your shear stress is nothing but I have just already shown you in the first figure. Shear stress what? This is the tangential. Shear stress is what? You just if you will see here, this is the tangential that is the force along the surface of your body. So here also you need to first calculate the force, that is the tangent force of the surface, then you can vary divide by area. Where it is here. So very thin film, let us assume this is the liquid film. Okay, and the your thickness is T, and moving in this direction, let us suppose. So shear stress is what? The tangential force divided by area. So now, what is the tangential force? If you will, this is your, let us suppose, weight of the liquid, and this is your W cos theta, if this will be theta, and this is your W sin theta. So what is W? Weight, that is gamma by volume, you know. So gamma is what? Rho into Z divided by volume. Volume is what? Area into thickness. So you can write your W is equal to rho Z A T. So you can write like that. So your force W sin theta divided by area, and what is W? W is nothing but rho G A T. This is your W sin theta divided by A. So what you will get? Rho G sin theta A square by T. This is your tau. If I am not going anywhere mistake. So this is like that. You will calculate your shear stress on the inclined plane. So remember please. So hope everyone got it, the concept, and similar concept you will apply in question whatever I was telling previously. You take the screenshot, that question you will apply the similar type of your concept. So hope everyone got it. So for today I'll conclude here. So maybe on next Friday we'll meet on 31st. So if anyone have any question, you can ask, please. Okay. If anyone want to ask anything, you can ask. Okay, thank you everyone. We'll meet again on the 31st next Friday. So thank you all. Bye bye. Yes, please. You can leave. You can leave the class. Please, everyone leave the class. Okay, thank you. Yes, Murmu, you can leave the class, please. Okay, thank you everyone.